In this video, I will show you how to come up with regression equation, correlation coefficient, and everything related to it. Okay, so first of all, let me go to one of the homework questions that we have in here. Let y hat represent the profit or loss for a company X years after 1970. Based on the data shown below, a statistician calculates a linear model y hat equals to negative 1.42x plus 35.85. I am just going to show you how to come up with scatter plots and how to come up with this equation. Since in my open math, if you copy everything, then the table will be copied as it is, either in Excel or in GeoGebra. Let's head over to GeoGebra and copy all the data up to this. There are 14 rows. Copy it, Control C, and go to GeoGebra. Okay, and then click on the first cell and Control V, paste them. And then you can see that there is some repetition. So let me just delete this. And I just want this to be X and this to be Y. There is some kind of formatting error, but however, that should not be a problem. You should be able to select this one, select the data. Okay, you don't need to select unnecessary cells. And then head over to this histogram like this bar like option. Click there and go for two variable regression analysis. Again, once more, select the data. Okay, just select everything and head over to this bar like option. Okay, and click it, and then you will be seeing two variable regression analysis. You can see the data is plotted in this way. So this is the scatter plot that you want. Okay, now you should be able to change residual plot or scatter plot. Now residual plot, you will be knowing that later on. We just need to go for a scatter plot only. Then after that, we need to go for a regression model. Okay, what kind of regression model would you like? We would want just the linear model. Okay, linear equation, or okay, so just write down the linear equation. Then it will show you a nice straight line which passes somewhere in middle of the scatter plot, and its equation is given in this way. Now you can clearly realize that this equation with this one, right, negative 1.42x 35.85. This linear equation is known as regression equation or least squares equation or best fit line. Okay? There are several ways to say. To figure out what is the correlation coefficient and what is the error or what are the residues and what is the mean of x and mean of y and everything, or standard deviation of x, y, you need to click on this sigma x. Okay, so let's go for that. If you click on sigma x, then it will give us everything that we need. Okay, so the mean of x, mean of this data set, the first column is 7. Mean of y, the second data set, is 25.9292. Standard deviation of x, standard deviation of first data point is 3.8944. Standard deviation of y, that is sy, is 5.6226. So this r is the correlation coefficient. Okay, r is the correlation coefficient, which is negative 0.9816. Right? Negative, what does it mean? It means that it is going downwards. Okay, so it is decreasing. Okay? So there's a negative correlation. Means if one goes down, another also goes down. Okay? If one goes up, another also goes up. That would be a positive correlation. And we already know that correlation coefficient always lies in between -1 and +1. If it is -1, then that's perfectly negatively correlated. If r is +1, then that's perfectly positively correlated. Now, if r equals to 0, then that's a no correlation. And this is the common standard deviation, and sxx, syy, sxy, these are the values we need to figure out the value of this coefficient. Okay, this coefficient or this slope. All these are the values that we need to figure out this slope of the regression line. R square is the square of this correlation coefficient, and it is always positive. Okay, since square means we multiply this thing with itself, so that's why we get 0.96. And SSE means standard error. Okay, that's standard error of this this straight line. Okay, so since we see that this equation touches few points of this scatter plot, it does not touch all the points, right? So there is some kind of residue, or there's some kind of errors while approximating all the data. Okay, if you want to predict some kind of future value or past value according to this regression equation, then there will be an error. So what is that error? This is the error. And then finally we have symbolic evaluation. So up to now we have all the values from 1 to 13, right? And we get the subsequent values of the corresponding values of y according to x. Now what if you want to pick let's say 10.5, corresponding value of 10.5, then you can write down over there 10.5 would give us is what? 20.9692. So you can see 10.5 is in between 10 and 11, and we also must consider that this 20.9692, it should be somewhere around here, and there is this standard error coming into play. Okay, we need to realize that as well. Now let us again go to the same question, copy this data, and we would like to paste that into Microsoft Excel. Okay, so open Excel and paste it over there, Control V. So you can see that everything looks fine except this X. I think we just need one X and this is one Y, right? So this looks fine. Okay, then then select the data points and head over to Insert and then go to Recommended Charts. It will easily give us all the charts that we want. Okay, so you can either click on Recommended Charts or you can go for all charts. Okay, so for this one, first of all, we need to go for the scatter plots, just like what we did in GeoGebra. Scatter plots. Okay, so for this one, we would go for this thing. Okay, not this one. It is showing two different signals. Okay, we don't want that. We just want this one. Okay, so that's good, and click on OK. So now if you are using Excel for the first time, then it will take some time to operate this. Okay, and then you might want to make this chart a bit nicer such that it will be quite easy for third person to look at it. So X versus Y. Click here to add axis titles. That will give us X. This is X. Enter, and this is Y, enter. Okay, so that's fine. And then we want to so this looks fine. Okay, and I don't think we need to do anything. Okay, so then to come up with a regression line, R square and everything, we click on here and go for trend line. Okay, so trend line is what we want. Okay, so go for trend line, put a tick mark on trend line and go for this small triangle and just click on linear. Okay, you can go for linear, but I would like to go for more options such that I'll have lots of things to do. Okay, that's it. All right, now we want to make this we want the equations, display equation on chart. You put a tick mark on that, then the equation is given over here, and also display R squared on the R squared value on the chart. And I just want to move it somewhere up so that I can see that easily. And then again I want to go for this one. Hold on, and click on this line. I want the color to be distinct for this line, so I would just go for red color. And the line, I want the line to be a nice one. Okay, something just like this. Okay, so that's all what I want. Okay, then you can clearly realize that the equation is y equals to -14171 x plus 35.85. Okay, so this is -1.42. Again, we got the same thing, and this R square is actually the square of this small r, right? Okay, so this is how you get the correlation coefficient in here. Okay. Now if you are confused, then follow this instruction again. Okay, that's all.